This little guy was printed using 27 different colors. But how is that possible on a printer that only supports 4? So let me explain you why it works and how you can do it on nearly every printer at home without any modifications, but also what problems could hit you. So you might have seen this printing methods over the past few weeks quite a lot, because in a subreddit there was something developed called Full Spectrum. Full Spectrum was a kind of an experiment started by Aceman, where he had basically the idea to stack different colors in a pattern in a z-axis to give you the illusion of different shades of color by just mixing whatever he has on the machine. Another Reddit user called Redo then took it and within hours, yes, literally within hours, he actually made a unique fork of the Snapmaker U1 fork of Orca slicer. Lots of forks. But he actually implemented the functionality of virtual filaments that take different color shades and then basically divide them into layers of different colors, thus creating the illusion of colors. But now this is actually available on more printers than just the U1. You see, when I heard of it through social media, I thought like, this is great. This is a big step in 3D printing and gives you so much capabilities. I, for example, immediately thought about my work when we do training models for surgeons. We want to have full color, so we use full color polyjet, which is hugely expensive. So sometimes if budgets are tight or they're throwaway models, we just print them using 2 or 3 filaments. But that always looks like comic-y. You know, when you color in something and you don't use a shade, then you actually get something that looks like a 3-year-old coloring book with just solid colors everywhere. And I thought with this you can do realistic anatomical models for surgeons or for teaching in the university or wherever. So I thought about porting the functionality of Full Spectrum into mainline Orca myself. But then, not a week after I started working on it, Bambolab actually came out with their own version, or let's say with a version, because Bambolab itself says that this color mixing filament of their program, of their fork of Orca Slicer Bamboo Studio, was completely independently developed of the fork that the subreddit users did. If that is true, I let you be the judge of it. What I already know is that Bambolab now credits Aceman already for at least part of this slicer. Let's go back to the idea itself. This method of mixing colors by making very tiny and very small dots of color is called dithering. Dithering is nothing new. We use it on printing every day. So when you really zoom in into a printed piece of paper, you actually see millions of little dots just made out of 4 colors, or 3 colors in that case. And you see them over here. They're called CMYK. K standing for white in that. And it's basically just the absence of color on a piece of paper. And sometimes we also add black into it to get deeper colors. So this is something you actually use every day, because right now you are using dithering to watch this video. If you really zoom in on the screen you're looking at, you see 3 individual colors. Again, you have red, blue and green this time, RGB. Perceives or tricks your brain into thinking it sees a mixed color. If you don't have an AMS system or you don't have the patience to wait for all those layer changes, you can just order your full color part with our today's sponsor, PCBWay. They offer a variety of 3D printing services, some of them full color, so go check them out. What you see around you is not really the thing you see. Everything you look at is formed or shaped by your imagination, by the way you've been brought up even, by everything your brain experienced through his life. What you see is a mix of information that is hallucinated by your brain. If you look at something, your brain perceives information, color information, form, shape, roughness, everything. That's a huge amount of information your brain basically can't handle. So everything you perceive is basically a mix of detailed information your eyes get, and your brain hallucinates the rest around it. It fills in the gaps. A great example of this is the blind spot in your eyes. You see where the nerve is attached to your eye, it can't perceive anything there. There is no sensory elements, no cells to get information out of that. But still, are you walking around with 2 black dots somewhere in your peripheral vision? I don't. But they are there. There's actually those cool little tests that we had in magazines in the earlier days, where you then have this and you close one eye and you start to move it away from you, and at some point a dot or a letter or whatever would just vanish. It would look like it was never there, and that is the blind spot in your eye. The reason why you don't see that blind spot is because your brain takes the information around it and just fills it in. Basically like a real-time version of Photoshop for you. And this is what dithering actually exploits. It takes the information matching or mixing that our brain does to make its job easier and uses it to produce different shades of color. So if you zoom in really close into this 3D print, you can actually see individual shades of just cyan, magenta and yellow. So by mixing this, you can get orange, you can get green, you can get purple, you can get yellow, you can get every color you wanted. So one thing I want to explain, you hear me a lot about talking about cyan, magenta and yellow, but before I said some screens use RGB. Why don't we use RGB instead of cyan, magenta and yellow? Because those filaments are more expensive. The thing is that cyan, magenta and yellow are colors that mix well in shadings, and RGB are colors that mix well in lighting. So you could say it's additive and subtractive in kind of a way. So if you try to do the same thing with RGB, every mix color you get is basically just gray. It looks like a mush because RGB needs light emitting to work, and cyan, magenta, yellow needs light reflecting to work. So now that we explained why this works, let's see actually how it works. As I said, we use CMYK filament here. They are actually sold in these neat little packages. Ours were kindly sent over by 3dstore.ch. They have a great store for everything you need for 3D printing, and they're actually good friends of mine. I buy all my material there, and I actually used to work there. So if you're in Switzerland and you need anything for 3D printing, check out 3D Store. Let's dive into the reality of 3D printing with this technology. What it does, already explained, is it alternates the layer with different colors to change the appearance of the part. But there is a difference how the fork of Full Spectrum does it and how Bambu Lab now implemented it. Those differences are important because there's ups and downs to it. Full Spectrum itself actually changed by number of layers. So you would have basically the same layer height, but you would then, for example, for a pink print, 2 layers of white, 1 layer of red, and it gives the appearance of pink. I think in the newer update, they also added changing the layer heights according to the part and also insetting color into the other one. So if you really want only to have a hint of it, you can actually have, for example, the white out and the pink a little bit more in, or the red a little bit more in, and this would change how light bounces off your part again. Bambu Lab itself gone down another way. What they do is they dither exclusively with layer height. So if you really zoom in into a sliced part, you will never see 2 layers of the same color on top of each other. It will always be a thick layer and a thin layer. Hey, Future Andy here. After playing around a little bit more with Bambu Studio, I actually found out there is an option that lets you go back to the printing strategy that Full Spectrum uses. So in layer height, you can uncheck the checkbox mixed color sublayers, and then it actually stacks an amount of layers on top of each other, and it's the way faster approach to do it like that. But if you activate it, you will take about 2.5 times more time to print your part, but the color mixing is way more consistent. So if you look sideways to your part, you actually can't see all the layers anymore because it does really thin color recessed into your part. So if you want to go for quality and printing time isn't of any concern, go for the checkbox checked. And if you want to print fast, all the way the same layer height on top of each other, and you are okay with a little bit more line artifact, get it unchecked. So let's get back to the video. when you have one solid piece that, for example, has different colors stacked on top of each other in the Z-axis, then Bambu Lab's approach might be faster, but I haven't tested that yet in depth because I don't have a SnapMaker U1, to be honest. So in the slicer itself, you can now set up something called virtual filaments. Those filaments, they don't really exist in real life, and they're also not mapped on the same slot. And behind every mixing, there is basically an algorithm telling the machine which colors in which layer heights it has to stack on top of each other. That also means in the moment you hit slice, it will actually all collapse down to your original filaments, and it will just calculate the different layer heights and the alternation between the layers automatically. This is a great design that also was already in full spectrum slicer, because it takes off algorithmic load. It's not a post-processing script, it's done before the slicing itself. So the slicer takes the information of the filaments that you have, and the virtual filaments, they actually collapse before the slicer gets the information. So there is no fancy calculation going on that might go wrong and mix your colors weirdly. It's all done pre-slicing basically, and this is great because it's very stable. I sliced a lot of different data just to see if I can stress out the slicer to crash, because it's a new feature, it should crash. It didn't. I took data up to 2 gigabytes and just sliced them. It took a while because it has to write, in my case sometimes, thousands of color changes, but it was super reliable. One thing though I have to say, another difference between full spectrum and the Bambu Lab color mixer is the way that they calculate mix colors. I think the full spectrum one has the right way of calculating it because the colors are more precise in my opinion. The Bambu Lab slicer uses a different kind, and you can already see that in my part. As soon as I added black into the mix, it kind of just looks black, with this one with like a little shadow hint of purple, even though this should be dark grades of purple. So the thing is that the algorithms, one is, you could say one is additive and the other one is subtractive in calculation, and the Bambu Lab one tend to give worse color accuracy, but I hope they will work on that in the future. But what you can do is just print some test pieces and just remember the color that is actually giving and not the color that is on the screen. So there are obvious downsides or issues to it. One of them, you might have guessed it, is time. Changing the layer or the color of the layer so many times takes a lot of effort in the machine, loads of color switches. It doesn't matter if you're on a classical machine or on a tool switcher, both take more time than a solid color. Of course, a tool switcher is way faster and it doesn't have to do all its purging stuff all the time, but also a non-tool changer takes quite a lot. This little guy, I actually lied to you at the beginning, this was not done on this printer. I actually made this with an H2D because I have 5 colors, not 4 colors. I have CMYK black, so that's why I have those shades. So this little guy took 1 day and 10 hours to print, because there was color switching and color switching and color switching. One side note actually, I was super impressed by the H2D that it didn't mess up the print once. It did thousands of purge sequences in one go over the course of 1.5 days, and it just did it without even stopping once. That should show you in what time we're living in. The reliability of 3D printer, I would have dreamed of that 3 years ago. But that's another topic. One other thing, and I can already hear you screaming at your screen, is like, oh my God.
Oh my God.
Purge waste. So yes, you can actually see the difference between my little guy here, we call him the Labmelian, and the purge waste it produced. I weighed it and I also checked in the software. We have about a 243 gram Labmelian, and we have nearly 500 grams of just purge waste. You throw all of that away. That is why the original full spectrum was actually planned to be on the U1 Fork SnapMaker orca, because there the perching waist actually is not really there. You have still the little perch tower, but you don't have all of this mess. One other issue I haven't seen anyone talk about, and maybe it's just me experiencing this, but because Bambu Lab slices with a layer height very light colorings, like here where I mixed yellow with a little bit of magenta, the layers of my cyan got so minimally thin that when I watched it while it was extruding, it actually didn't really extrude anything. It was kind of like pressing little fragments of color out, which I think is cool because it pressed it really into the, again, molten layer below it and changed the color of the filament. So here you can actually not see the staggering or the dithering of the layers, but also it gave me weak parts. So there are a few parts, for example, here on that purple one where you have a lot of white and a little bit of cyan, and so the little bit made it that I can actually see through the outer perimeter of my part. So it might produce weak parts. I have to test it a little bit more. If you want to see more about that, leave a comment down below if we should really dive into it. There's also one more thing I want to say or put out there. Maybe someone else wants to test it as well. If we can do that with colors, can we do it with different materials? What I'm thinking about is using dithering to do new filament blends out of base material. Just imagine having a nylon mixed with a TPU by dithering, if they connect well to each other, but we can do that mechanically as well a little bit. So we can give one filament some properties of the other filament. For example, have the high shear stress that nylon gives you combined with like the bounciness and the absorbiness of TPU. I'm really eager to look in those kinds of experiments, and if you want to see that as well, let me know if it's worth to have a look into that. I think it's exciting times we live in, especially if you're interested in 3D printing. The market is moving so fast. Seeing something like this come from idea to market within basically a few weeks is just baffling to me. So thanks for watching. Consider subscribing. You're helping us a lot to make videos like that possible. And maybe you're interested in another video of mine. Thanks for watching.